Hi, welcome to our submission for the Smarting Spectra Hyperscanning Contest. Our project is titled Exploring Empathic AI with Hyperscanning, and my name is Zane Karai, a PhD student at the Empathic Computing Lab at the University of Auckland, New Zealand. In my current work, I am part of a Royal Society-funded study about interpersonal synchrony and the translation of multimodal data between real-world and virtual reality. In particular, my work examines dyads and collects data from motion capture, eye tracking, EEG hyperscanning, heart rate, and skin conductance. My background is in cognitive and computational neuroscience, and I've worked as an EEG research assistant across these labs over the last 5 years. The lab is led by Professor Mark Billinghurst. Professor Billinghurst is a distinguished researcher across AR, VR, HCI, and physiological sensing fields, just to name a few. He's the director of the ECL and has published numerous papers involving hyperscanning, empathic AI, and remote collaboration. So now that that's settled, let's talk a bit more about the project. Our background and motivation mainly stems around that student lives are full of stress. And on top of that, sources of stress are around every turn throughout their academic lives. Some of us may remember missing out on important events, meetings with loved ones, and not having enough money for even a coffee. So our question is, how can we design accessible solutions to help them throughout their journey? Currently, students in New Zealand have very few options for accessible dialogue. It's either empathizing with their fellow students, or getting stuck in a potentially depressive rumination at home. So it's clear to us that we want to target a pro-social setting rather than a potentially anti-social one. Currently, large-scale implementation of AI assistants in conversational settings, such as Zoom or other meeting places, has taken precedence in facilitating effective and engaging dialogue between co-workers. And now we can see the scope of AI has been extended into people's personal lives and their feelings. However, there's always a drawback. And whether that drawback is some personal privacy reasons, there is still something missing. But what exactly is it? Beyond disclosing personally sensitive information, there needs to be that level of trust between the audience and its agent. In particular, we want to see an agent that is open to awareness, have an unconditional positive regard, and most importantly, be available when you need them. So, where does hyperscanning fit into this? Student stress is more than a one-person ordeal, and a solution should be presented from the perspective of those affected. We chose hyperscanning as it addresses the following gaps. We want to establish neural evidence that supports when group perspective sharing is accepted by the individual. We also want to see the biological utility of synchrony during shared experiences, such as apprehensiveness, all the way to trust building. By doing so, we can develop on previous experiments that explore emotional eliciting scenarios and the efficacy of them. And lastly, we want to examine if can an accessible agent replicate features of human-to-human interactions that mitigate symptoms of antisocial behaviors. And to accomplish this, we'll use the ECL's AI digital human agent, Rangi. We'll be using him to assess whether humans are equally responsive towards empathic AI or human-trained interaction partners in focus groups. Our lab has tried to develop hyperscanning solutions with equipment from other manufacturers, but we decided that the Smarting Mobi amplifiers suited our lab's needs and have been satisfied with them so far. The automated ASR algorithm is an added benefit. As any EEG data analyst would know, movement artifacts are always a pain to deal with. Lastly, we used our in-house developed synchronization software for multimodal data acquisition. Having access to your software streamlines our previous methodology and has lower odds of technical errors and data loss. Our expected outcomes and contributions are as follows. We believe that the facilitation modality between human interaction partners and AI will produce strong differences in interbrain synchrony strength and network topology. Next, we believe that synchrony dynamics will correlate with behavioral coordination during emotionally salient segments, and this leans more into our multimodal exploration of synchrony as a whole. Lastly, our contributions to the field are advancements in our theoretical understanding of interbrain synchrony as a marker of perspective sharing and social coordination. Lastly, our feasibility is stretched over the course of April to October, and that starts with an ethics amendment, followed by pilot testing, recruitment, and group data collection all the way up until the equipment return in October. Our main dissemination plan is based on a strong public engagement strategy, and future journal publications alongside conference submissions. And lastly, from our team to yours, thank you for listening and thank you for the opportunity.